Look at this rapidly expanding network. It represents a shift in how we build. Developers are moving away from writing lines of code by hand and instead handing complex web tasks to autonomous AI agents that execute them without human intervention. You do not need a technical background to use these systems. By providing clear directions, a user can construct functional applications and analyze massive, disorganized datasets. In this tutorial, we will demonstrate this capability in 3 parts. First, we will generate a financial dashboard from local files. Then, we will build a gamified learning application from scratch. Finally, we will deploy an autonomous agent to research the web. These workflows allow anyone with a basic Google account and raw data to launch tools that previously required a dedicated development team. Step 1 is configuring the Antigravity 2.0 environment. During the initial setup, the software offers various toolkits. Leave those unselected for now. Starting empty gives an uncluttered workspace for our custom build. Next, we select our model. We will use Gemini 3.5 Flash. Its primary advantage is a token output speed that outperforms other leading models available right now. For our first project, we grant the AI workspace direct permission to read a local folder. This diagram shows how raw files are processed. The AI reads disorganized CSV files containing sales and competitor data, funneled into a readable format. We instruct it to cross-reference that data and build a unified interface with a left-hand navigation column and interactive filters. A minute later, it delivers a completed HTML file. Opening it reveals a working dashboard. The dynamic filters actively sort the product categories, the interactive graphs track competitor metrics, and the business simulators update revenue forecasts based on the specific local data we provided. In under 60 seconds, we translated a chaotic local folder of unstructured data into actionable business intelligence without writing code. Now we initiate a second project. We will create a gamified language learning app featuring 3 distinct subject paths and a frog mascot. After one prompt, the system generates the baseline mechanics. The app has locked progression paths that require completing previous lessons. Inside those lessons are matching definition games, and the mascot reacts to your performance, becoming happy or sad depending on your accuracy. To accelerate development, we introduce parallel sub-agents. We instruct the primary AI to simultaneously build a night mode, research external viral features, and draft a new course. Opening the Task Manager, you can watch the system operating. The central AI splits into 3 distinct processing streams, executing assigned research and development tasks simultaneously. Once finished, they converge back into the main project. The live application updates immediately, featuring new emotional states for the mascot, a dark mode palette, and the newly researched course. Utilizing a parallel agent architecture allows an individual to operate with the efficiency of a synchronized development team, multiplying their total output. To navigate these projects faster, Antigravity features a command bar interface. Typing a // pulls up a list of tools. The browser shortcut is specifically designed to command the AI to interact directly with external web environments. When activated, the artificial intelligence takes over the browser. It navigates the maze of the target application, clicking buttons and completing tasks without manual input. Next is the goal shortcut. When you enter a prompt using this command, the AI is instructed to construct a complete application autonomously, finishing the project without pausing to ask for user approvals. In contrast, the Grill Me shortcut reverses that dynamic. It forces the AI to aggressively question you, requiring you to refine project specifics before it begins any construction. Implementing these specific command shortcuts allows the user to maintain a high-level strategic oversight of the project rather than managing individual tasks. We can also establish autonomous routines. Using the scheduling tool, we can set up a recurring daily morning task for the AI agent. We configure the parameters. Every day at 9 a.m., the agent scans external forums for competitor app feedback and compiles those data nodes into a summary for us to review. In the advanced account settings, you can manage your model allocation. If your primary model reaches its usage limit during one of these tasks, the system can switch to an alternate model to continue the workflow. There is also a specific setting that prevents your computer from shutting down or going to sleep. Enabling this converts your local machine into a persistent, always-on server for your agents. Coupling scheduled AI workflows with persistent local hosting yields an automated asset that operates continuously in the background. We started with a blank workspace. By giving clear instructions, we transformed it into a live BI dashboard, a gamified application, and a self-researching local server. These results show how directing autonomous software agents can now handle the creation and management of complex systems. If you found this guide helpful, subscribe to the channel. This will surprise you. Comment below with your ideas for what workflows we should automate in our next video. Thanks for watching. Hit the like button to support more cinematic AI tutorials regarding futuristic technology and cybersecurity.